whole concept of what we're working with is very different from what we started with, which is why I don't choose to start with this the first few weeks of school, okay? Because in my opinion, it would kill the class and y'all would all be like, I hate chemistry the first 3 weeks of the semester. All right? So, I mean, most people just don't care for it. Now, so, I'm going to work with 2 examples of how this works, probably Thursday. I think we can get through enough today that we can do it on Thursday. Neon lights are one example, and the photoelectric effect are the second example. Yes. The photoelectric effect is the one I was trying to describe when they called us to the auditorium. So picture a metal like aluminum foil, shine light on it, and an electron or a particle is going to be ejected by shining light on it. Okay? Now, that's a foreign concept to most of us. All right? When we throw something in a can, we knock the can down because it's matter. Matter will move when a particle or a piece of matter hits it. But to just shine light on something and a particle move, most of us can't relate to that. Well, that's what the wave particle nature of light is saying. When we shine light on a metal, an electron, which is a particle, can be ejected from the light. Okay? That's what that's saying. Okay? Now, because we're going to talk about light being able to eject electrons from a metal, then we need to have some understanding of what light is. Now, we use light often in a generic sense. But in science class, we need to probably use the correct language. So light is actually electromagnetic radiation. So what is electromagnetic radiation? First of all, you can abbreviate this EMR because writing electromagnetic radiation out gets a little cumbersome. And a lot of people just get tired of writing it. But it's a form of energy. That travels through space with wave-like behavior. Now, you guys are actually familiar with electromagnetic radiation, more so than you think you are. Depending on your background in science in 8th grade, you actually had probably talked about the examples, probably talked about 3 characteristics of electromagnetic radiation. I know Angel has because he had me last year in physical science, so he's had quite a bit of background in this. So, can anybody think of any examples of electromagnetic radiation? UV, that's one. Does everybody have this? All right, Anthony said no. Because we're going to write the examples on the next board. UV is one. Ultraviolet. Can you give me another? What? X-ray.
Like gamma.
Gamma. Does everybody have it now? All right, so ultraviolet, if I can remember what you said, which we often abbreviate UV, X-ray, gamma, there are. Huh? Yes. Infrared. Infrared is abbreviated IR. Microwave.
Wait, isn't this one on part?
Yes. It is.
Radio waves.
Radio waves.
Yep. Radio waves.
Invisible. No, wait.
Yep. Visible light.
Visible.
Visible light is the only one we can actually see. Okay? We cannot see radio waves. We cannot see ultraviolet. We cannot see IR. We cannot see, what else did you say? X-rays, gamma rays. We cannot see anything. Okay? The only one that we see, okay, is visible light. All right? It's the only one we can see out of all of those. Now, if you forget those, if you turn to the very back page of your blue chart, and I'm just going to hold up Angel so you don't have to all drag it out. All right? It's at the bottom on the blue chart. Okay? We'll talk more about that in a little while. But you can look up the types of electromagnetic radiation. Now, how can we tell the differences between the various types of electromagnetic radiation. All right? Well, there are two things that make UV different from IR, or make gamma rays different from microwaves. For example, we can use microwaves to cook our food. Gamma rays we wouldn't want to use to cook our food. So, how do we tell them apart? Wavelength is one, frequency is the other. Okay? So, we use wavelength, and we use frequency. Okay, we use wavelength and frequency. I'm pretty sure I have a board for each of these. Let me look. Yeah, I do. All right, now, everybody got it? Y'all are back fast. Did you even take time at the reception? Yes, but I've got it on a separate board side because I'll write quite a bit for frequency. All right, everybody there? So, for those of you who don't have out your blue chart, all right, what is the electromagnetic spectrum? This is what it looks like on your blue chart. Anybody tell me what that is?
Super short, super long waves. Scale them up.
Not bad. What do you mean by scale it out?
Like it shows which ones are more closely related, which ones have longer waves, which ones are wavelengths.
Okay. Okay. All right. So basically, it is a scale that shows all types of EMR arranged by what? Yeah. Now, I used our definition based on wavelength, whoops, because that's the way our electromagnetic spectrum is arranged. Now, different textbooks and different charts arrange it different ways. It will always be in that order, but some textbooks will arrange it instead of arranging it by wavelengths, they'll arrange it by what? They'll put it arranging by frequencies. Now, it'll always be in the same order. The numbers will just be different because they're using frequency numbers, but the order won't change. Some textbooks will even show both frequency and wavelength, so you can see both numbers. Our chart is only going to show wavelength, okay? So one of the things we're going to learn to do today is to calculate the frequency, which is why I said there will be one math calculation in 4 weeks. Because our chart is only going to show us wavelength, we have to be able to calculate the frequency. Does that make sense? All right. So if you don't know what type of EMR, want to find it, you can find it right here. Now, if you look at the chart, notice it has short wavelength, long wavelength. So if I ask you a question about which of the following has the shortest wavelength, do I expect you to know that off the top of your head? No, but I do expect you to have enough sense to look at your reference table, find where it says short wavelength, find where it says long wavelength, and look it up and compare. Okay? Notice that microwave and radio waves overlap. So technically a microwave is a type of what? It's a type of radio wave. Okay? Visible light is right here. It expands down to the bottom. So shortest wavelength would be the violet. Longest wavelength would be the red color. Okay? Everybody go to that? These numbers are wavelengths. They are all times 10 to the negative 7th meters. This is a 4. That's a 7. We're going to talk about those in nanometers in a little bit. But they're all read in meters, and these are all times 10 to the negative numbers until you get about here, and then they become positive numbers. Okay? Everybody okay with how that's read? Fabulous. All right. Now, this is the part where if you had a good middle school background with frequency and wavelength, everything I'm going to talk about is going to be reviewed for probably 20 minutes, okay? If you had a terrible middle school experience and you had the subs and all you did was get it out of a book, you will probably not remember any of this, okay? So, what is wavelength? Wavelength is the distance between two corresponding points on adjacent waves. Okay, it's the distance between two corresponding points on adjacent waves. Now, if you tell me that it's the distance between two waves, am I going to take it? No. First of all, you can't ever define the word using the words in the literally the word. You can't tell me the length of a wave, all right, or the distance between two waves. So, what do I mean by the distance between two corresponding points on adjacent waves? Well, first of all, can you tell me what this and this are called? Some people know, but some people don't at this point. So, what's this called?
Crest.
All right, that's called the crest. So, I'm going to label this one down here. All right, the crest, for those of you who don't know.
Teachers, the students from the induction ceremony should be in the classrooms by 10 o'clock. I would just like to commend the student body for giving the respect that they did to the ceremony today. We appreciate your behavior, and we are sure that we will be able to have more events like this in the upcoming future. We also would like to commend Mr. Zellman for organizing the program, Ms. Henson for conducting the services and behind the scene, all the organization that she did along with Ms. Harvey and Mr. Mumford. We also would like to commend all of the sponsors, Mr. Estrada, Ms. Wells, Mr. Wadey, Dr. Duncan, for all of your assistance in pulling these students together and ensuring everything took place today. Thank you so much for all of those who assisted in preparing for the ceremonies. Have a great day.
All right, so what would this point right here be called? T-R-O-U-G-H. The G-H is an F sound. That's the trough. The trough is the lowest point on the wave. Now, in order to have a wave, you have to have both. Okay, I'm just going to box this in. Whoops, for just a second here. That's a terrible line. Let's try this again. Okay, that right there would be a full wave. Okay, a crest and a trough. So you have to have both parts to have a full wave. Okay, does everybody remember that from another science class? That look familiar to anybody besides me and Angel?
I remember not that part, but
You remember the other. Okay. So when we're counting waves for frequency in a little while, that will be important. Okay. So in order to have a wave, you have to have a crest and a trough. That makes one wave. Okay. That would be one wave. Okay. Because you have to have a crest and a trough. You can't have one or just a half. Let me say this. If you only have a crest and no trough, it's a half of a wave. Okay. Which will be important when we're trying to calculate frequency. Now, if we want to measure a wavelength, the easiest way to do it for most of us, because we want to go from corresponding points, would be to go from where to where. What do you think? Crest to crest. Yeah. So if I went from this corresponding point, now what's adjacent mean? What? Next to. Okay. So if I went from this crest, I could go to this crest. That would be a wavelength. Now, do I have to use a crest though? No. I could just as easily have picked this trough and gone to this trough because those are two corresponding points and they're side by side. That would be a wavelength. Now, I don't even have to pick a crest or a trough. I could say this point here going down on this wave and this point here going down on that wave. That would be a wavelength. That's why when we do this, left down knee. All right. We don't have to necessarily say the wavelength is the distance between two crests, the distance between two troughs. It's distance between two corresponding points. And they have to be on adjacent waves. They have to be side by side. Does that make sense? All right. So what else do we need to know about this? First of all, we're going to calculate with this. So it has a unit. The unit can be in meters, or it can be in a new unit for us, which is nanometers. Okay? Nanometers is going to be abbreviated NM. And the symbol we're going to use for it is a Greek letter called lambda. 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 And it's sort of an upside down Y. And you'll see it in the math formula. But it's a Greek letter called lambda. What's wrong? Oh. I told you it's very different from what we've been doing. It's on YouTube also, or you can get the notes from somebody. I recorded it. It's just in part 2 of the video, and I'll post both of them later.
So all of them got wavelengths?
Yep, all of them are wavelengths because they're all from corresponding points on adjacent waves. So adjacent just means side by side, and corresponding just means the same point. So like we went from this crest to that crest. So these crests are on waves that are beside each other. So from this point to that point, but it doesn't have to be a crest. So you could use a trough. So we went from this trough to the trough that's next to it. That would be a wavelength also. But you don't have to use a crest or a trough. They're just the easiest ones to use. So I said we could do from like the midpoint of this wave going down to the midpoint of this wave going down. Okay, but you don't have to. I mean, it just has to be the same point on the next wave's same point. Okay? Now this was illustrating what a wave is. A wave has to be a crest and a trough together to be a full wave. You have to have both. Okay? You have to have the crest and you have to have the trough to be a full wave, which will be important when we talk about frequency in a minute. Okay?
So if you ask how many waves you have, on that you would have 3.
That is correct. There'd be 3 waves in this particular drawing.
Okay.
And the crest is the high point, the trough is the low point. Okay? Are we good? Almost. Look, now I can't wait on everybody who comes in late here to copy this one board. Okay. It is on YouTube, I promise. We're recording. And your friends all have it. They'll be glad to share. They're nice that way. Right, Lolly?
Most of them.
Most of them are. Lolly's pretty nice. She looks like she's in a better mood today. Any fingers? Are they better? They're okay?
You will never not get on here about that, will you?
Well, I'm worried about the next lab.
Oh no. Does it involve fire again?
No, it only involves chalk. We should be okay. We're going to do it, as long as I don't change next week's half a day, we're going to do it next week. As long as it stays a half a day.
We don't have school the next day, right?
No, not unless they change it.
Oh, it's gone because of the
Because
day.
It's parent
So we
conferences.
get into school early on the 31st, we won't have school.
The first. Right now, that's the way the calendar works.
But there's certain days they can just waive, right?
We've already waived 2 full days, so I don't know if they'll waive anymore. Because they waived the 2 days from the first hurricane. So I don't know if they'll waive the next day. We'll just have to see what they do with that.
The bottom is the crest and the top is the peak.
The top is the crest, the bottom is the trough.
They should have like a deadline.
So I don't know. But since the next school board meeting is in November, I don't know if they'll make a decision on days before the next school board meeting. So that's why. But the half day is a good day to do this next lab because the next lab is pretty short. But there's no procedure for the next lab. Y'all have to create the procedure, the data table, everything. There's no, but you only have chalk. So nobody should be able to injure themselves in this lab. All right. Everybody should be safe. All right. So what's frequency? It's just sidewalk chalk, people. You should be fine. How many times a wave? Yeah, basically. All right. Number of times a wave passes a given point in a given time. Now, typically people use 1 second, but it doesn't have to be 1 second. Okay? So that's why I said in a given time. So when we want to calculate frequency, frequency actually has a formula. So based on our definition, it's the number of waves over the time. Now, when we do this in physical science, I make students draw waves, and I let them pick any time they want to pick when they draw their waves. And they pick the weirdest times, all right? And I can't convince them that when we're doing this, what's the easiest time to pick for your wave?
1 second.
I know. So every time I draw a wave, and I use an example, I put 1 second at the end of my wave. They put 13, 17, 24. I'm like, what? Whatever, dudes. All right? So they have 3 waves, and they got 24 seconds at the end. And then they're like, why is my frequency so weird? Dude, you picked 24 seconds. 3 over 24 is going to be a decimal every day of the week. All right? So when we want to calculate our frequency, we do what Almaja said just a second ago. How many waves do you have in this picture? Well, what did we say make up a wave? A crest and a trough. Now, you don't actually have to count the crests and the troughs. You just need to make sure you have the same number of crests and troughs. You have how many crests and how many troughs? 3. As long as they match, you just have to go along and say 1, 2, 3. So you have how many waves? You have 3 waves. So we have 3. Okay, so we have 3 waves over what's our time? So we get 3. Now, we have a unit for frequency also. The unit here is hertz. So we have Hz if we want to abbreviate it, and that means 1 cycle per second. So when we got that 3 up there, we're going to write Hz.
Doesn't like have to do something with sound?
Yeah.
Or is that decimals?
You can talk about decibels too. You can talk about loudness and pitch. Loudness is about amplitude and how tall the wave is, and pitch is frequency. So for those people who talk and they're really loud, they're going to have a really high amplitude. And for people who are quiet, they're going to have a low amplitude when they talk. And people who have a really shrill voice, they're going to have a higher pitch. Your sopranos are going to have a higher pitch, and your basses are going to have a lower pitch. And that would be your frequency. But that's not part of our curriculum. I would teach that in physical science, but even that's been taken out of the curriculum at this point. All right, are we caught up? All right, so the symbol, because remember, we're going to do math with this in just a second. All right, so the symbol for frequency is nu, and it's an italicized V. Now, I can't italicize a V when I write. I'm just not that good. So I just write it as a V. Now, when I type it on the test, I can italicize it, okay? But when I write it on the board in just this little pen, it's just going to look like a plain V, okay? Huh? It'll be slanted slightly on the test, but For right now, it just looks like a plain V, but it'll be italicized on the test or on a quiz because I can italicize it when I type. I just can't italicize it when I write. I tried slanting it for years and my students told me to quit, so I've quit.
Can I see it? So
No. No, it just looks bad.
Just try it.
What is it?
You see, it doesn't look italicized.
It's supposed to be slanted the other way, isn't it?
I have no idea. Why do you think they told me to quit? All right. So higher frequency and wavelength related. Any ideas? It's a math relationship.
Yes.
They're inversely proportional. All right, think math class. What does the word inversely mean? Opposites, okay? So, they're opposites of each other. So, what does opposites mean for us? If wavelength gets bigger,
Frequency is one.
yeah. So, for the entire semester, if one quantity increases, the other decreases. Okay, that's what inversely proportional means. So, this is why our electromagnetic spectrum only has wavelength on it, because the state wants you to know that relationship. So they don't put frequency on the chart, okay? Because they want you to figure it out. So let's say, and I'll come back to this equation. I don't think I have it here. Okay, I can put it there though for just a second, and then I'll just put it here. All right, let's say those are the 4 choices on the test. And you have this question. And I'm asking you, all right, which type of EMR has the lowest frequency? And I have those 4 answers. Okay? And I have these 4 answers. How would I figure it out?
What is the longest wavelength?
Okay, so first thing I do is pull out my what? Your chart, your reference table. I don't expect anybody to know this off the top of their head. All right, so when you look at your blue chart, let's see if I flip back here. I'm coming back. I'm going back. All right, so if you look here, what do you know about wavelength? Shorter wavelength means what? All right, that's a higher frequency. Do not write this on your blue chart. You'll be borrowing mine on test day. Longer frequency means what? Means lower frequency. And if you want, I'll write this in our notes in just a second. Okay, so what were the questions? Whoops, too far. What were the choices that I gave you? IR, UV, visible, and microwave. So when you look at those 4, who would have the lowest frequency out of those 4 choices? Okay, microwave. Questions about how we would make that choice?
Wait, what did you say? The higher the this, the higher that.
All right, so your chart had what? This way it said short wavelength, and this way it said longer wavelength, right? So if it has a short wave, that means what about frequency? It has a higher frequency. And if it has a longer wavelength, it has a lower frequency. And I can draw that if you want so you can see the waves. I'll wait. Yeah, it's chilly in here for those of you who are putting on stuff. I've emailed Ms. Beverly about the fact that there's no heater or anything on in here.
It's okay, I've already lost feeling with this.
You've already lost feeling in your toes.
Yeah, I think my shoes go on.
Smells great.
I really have to use the bathroom and it's exacerbating the problem. So,
You can trust us.
yeah, I know. But,
That was right.
But she's keeping outside.
I can go inside or outside. It doesn't matter. It's good for the soul.
What's good for the soul?
Having to pee and it's cold in here, so I just dance a little more. So 10:50.
50.
Yeah, you gotta make it to 10:50. I can do it. So why when people tell me they can't, I'm like, yeah, you can.
I mean.
All right, has everybody had time to write? All right, and we're giving everybody enough time. All right, so if we look at the waves, okay, let's say I draw a wave.
That's cute.
I can't draw it at it.
She just, oh.
I've had a little more practice with this than y'all have. Okay, let me make that one a little closer. There, that's a little better. If you want to, I'm just going to explain the relationship. That's all.
I went to the movie Saturday and the movie started skipping. At cinema. Yeah. But I was like, I'm not coming back here anymore.
I remember, like, before they closed and then reopened, they forgot to put the movie on. We sat there for like 30 minutes
Yes.
waiting on it.
No.
You're kidding.
And on the left side, oh no, the right side, who's looking down? It's a heater in the arrow. And then the theaters are closed.
I think we went to see them.
No,
The outlets too. They had it planned, but it wasn't on the screen.
Michael Myers like,
Right back.
It's like, it's illegal. Illegal.
Okay.
You watch the movie like a movie in a movie theater.
Okay. I don't remember the last time I went to Cinema 8 here. It was probably when my kids were little and they were doing those dollar movies in the summertime. It's been a long time. All right. So when we look at that, all right, we can all agree this is wavelength, right? All right. So, what can you tell me about that wavelength versus that wavelength? Okay, so this one's a short one. And this one is a what one? Okay. Now, that's long, that's short. Everybody okay with me on that one? Okay. So if we look at the relationship, now let's talk frequency. All right? And I'm not even going to worry about putting a time in. Basically, I have how many waves in this top one?
3, 2, yeah, 3.
1, 2, 3. Okay? So I only have 3 waves up here. All right? How many waves do I have down here? A lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? That's okay. The point I'm trying to make is when you have a short wavelength, what does it do to your frequency? That's right. You have a high frequency. Okay? Basically, you have more waves. When you have a short wavelength, it means they're closer together. You have a high frequency. But when you have a long wavelength, they're spread out. You have a low frequency because you have less waves. Does that make sense? Okay, that's basically why they're opposites of each other. Are you with me on that? Okay. Now, how do we calculate mathematically? All right, this formula is not on the reference table. It's one you just have to learn. All right, let me do this. All right, the formula is C equals lambda nu. Well, a lot of symbols in chemistry and physics are Greek letters. Okay, so C.
Wait, is this the equation that was on the other slide?
On that one where I scratched out the word equation and just kept writing?
Yeah.
Yes.
What is it?
That's lambda. It's a symbol for lambda. It's an upside down Y. Okay. So we labeled that as lambda a while ago for those of you who came in late. Okay. That's the Greek letter lambda. All right. What did lambda stand for? Didn't y'all ever watch the old movie from back in the 80s called Revenge of the Nerds?
No. What is that?
Huh? It's a stupid movie, but it was funny. But there was a fraternity in there, lambda, lambda, lambda.
Well, since this seems related to chemistry, can we watch it?
No, I don't think it's appropriate for the course at all. And I might get fired. No. All right. Y'all watch it. I'm not watching it here. All right. Yes. Revenge of the Nerds. I'm not even sure what the rating was on it, but I'm not watching it in here. It's possible.
It's probably PG-13.
It's entirely possible back then. I don't know, but we're not watching it. All right. V was what? That's the Greek letter nu for those of you who came in late, and it was frequency. Okay? So, the speed of light is a constant. All right? The speed of light is a constant, and you have to know the constant. It's 3.00 times 10 to the 8 meters per second. Okay? Now, to illustrate how fast that is.
It's stupid.
All right, so if you look at one tick on the clock up there, one tiny little tick of that second hand, light travels 300 million meters. Okay, I don't have out a meter stick at the moment, but roughly that far, 300 million of those in one tick off that clock. Okay, that's fast. Now, the only thing that's moved faster than that right now is there are scientists in France who say they've moved an electron faster than the speed of light, and I think it's a proton accelerator. Other than that, nothing has moved faster. Okay?
Now,
Now, yes.
I made a camera to.
that was the most annoying show.
The light.
I mean,
You know what I did? Like,
Netflix adaptation.
they just took a lot of frame, like a lot of pictures per frame, and they just. But it's like light.
Cool. All right. Now, we have to calculate with the formula. Okay? So, write it down. This is our only math calculation for 4 weeks.
I mean, I would only cover 15.
We only have one. This is it. Hey, we've been doing hard math for a week. What's one little math formula for 4 weeks?
Oh my God.
No wonder you haven't, just lost your mind over the last. You're really close.
Earlier you were already
I know Wally does. And there have been times I've been fearful for my life when I get up close.
I don't hate you as a teacher, you teach very well, but I hate you.
It's okay. I get that a lot.
Love who you are, hates what you do.
Yes, actually, all you have to do is just stupid ACT words, and that's why you're gonna actually know I was there.
She was there. There was.
Can't go happy.
She was there and everything we talked about.
Oh, you didn't know Mr. Justice on the definition? You
Right.
guys read the criminal.
He signed the Declaration of Independence and he helped with the Boston Tea Party. He
Really?
He helped organize it, I'm serious.
Like Mr. Justice,
He told us.
He's that old?
he
No.
teaches us like he was actually there.
Wow.
Like
He
said-
knows him personally.
Oh, okay. Yeah.
Hey,
I'm sure that's
it's from British.
Lolly loves what I teach him. All right, so you're gonna he's gonna get a reprieve because I'm gonna have to go to this parent conference. All right, so no, so no, I'm enjoying them. So what do we do if we want to find the color and the frequency of light? No. So how do we find the frequency? All right, we're gonna need a chart to find the color. All right, so the first thing we need to do is what? Sailor, you got your hand up. You gotta have some idea. You raise your hand. Let me ask Mark. That's not the right answer. It's not a phone or a helpline thing.
Oh.
Your hair, like,
Is it?
Take a guess.
No.
It's my weakness. Not on diet. No.
Oh my God, you had to go on a diet when we got started.
Hey, I lost 26 pounds since August. Y'all stay away from me.
And I knew what you
You gave up Pepsi.
I did. I haven't had one since August 1st.
August 1st.
No, I've done other stuff too. I even ate broccoli last night. I can't eat broccoli.
I ate broccoli last night.
I can't eat broccoli. Oh, you can freeze broccoli. I like broccoli. You can't do
Broccoli is good. I had broccoli last night.
I can do llamas. I just have to be selective about when I eat them.
that will be a texture.
What's wrong with you? Don't think it'd be protein. Broccoli
They
is.
do, but on Weight Watchers, they're point, so I stick with free vegetables. They are. Alright, so when we look at the formula, alright,
Yes.
we have, because I'm gonna have to leave in about 10 minutes. So C equals what?
It's 10:30. It's 10:30 right now.
Yeah, but she said she'd send Ms. Byerly down in 10 or 15 minutes. So C is 3 times 10 to the what? Now, here's the catch. It's meters per what? All right. We're solving for frequency, which is what? Which letter is frequency?
B.
The V. Now, here's the catch.
What does the dot mean? Is that
The times. Yeah. This is in what unit? Does it match?
No.
What did we learn way back at the beginning of the semester about units have to do what? They got to match. We got to change it.
It's nanometers.
Are we on a chart?
Yes.
Wait, go back. What did you say?
We have to change it.
Change it.
We have to change.
All right. Here's a new conversion for you in red. 1 meter is equal to 1 times 10 to the 9th nanometers. I like y'all are wonderful people, but you still have to learn it. Okay? It's just part of the curriculum.
I like to know good old Roy Cooper.
Good old Roy Cooper doesn't know it either.
Exactly.
Why do we have to know it?
Because you want to go to schools that require chemistry in your transcript.
I don't need it. I can be
I didn't need to read Beowulf as a senior either, but some fool thought I needed it. All right. So, nanometers to meters. Again, who's bigger, meter or nanometer?
Meter.
Put a 1 there.
I'm gonna just get it.
How many nanometers are there in a meter? What's on the board in red? Not a lot. So you write 1 times 10 to the 9th. All right. Now use your trusty calculators and let it do the work.
Wait, so how did you figure that out?
Oh, that is a lot.
How did I figure it out? I just told you.
But you,
You have to memorize it.
meters are bigger than nanometers.
Yes. Nanometers are tiny.
Because nano is small. So nanometers is small.
It's small.
He said
You could study nanoscience. There's a whole unit of science called nanoscience. What?
4.5 times.
Nanometers is below centimeters. You'd have to go down. There's micrometers, and then there's nanometers.
So we're not going to learn about any other meters.
There's picometers too.
Wait, is it always meters and nanometers?
You got the baseline. You have deci, centi, milli, then micro, and then nano, and then 3 more, and then pico. That's times 10 to the negative 12.
Okay, so will it always be nanometers and meters?
Yes.
Is there another conversion?
No.
Wait, it's called, what is it, King Henry?
King Henry died by drinking chocolate milk.
Wait, so what unit is the V?
The V is hertz.
That doesn't matter.
All right, so where do I put that 4.5 times 10 to the negative 7? That's your wavelength, right?
It's more to it.
Yeah, we got to solve for the V. All we did was change the unit to meters. Now we got to put it here. Now how do we find the V?
No, you divide that.
Yeah.
That's a multiply, and we want the V. So what's the opposite of multiply?
Yeah, that's fine.
I was hoping.
Yeah, sure you did.
Yes?
Coral.
That movie messed me up.
That movie is terrifying.
I hate that movie.
I got it first.
And my grandma said, oh my
It
gosh,
doesn't-
how's your name?
it's a great
in it?" Oh,
movie.
I hate these so sad.
Well, watching it now,
To a little
I realize
6-year-old.
All right, so 3 times 10 to the 8 divide 4.5 second EE negative 7.
I got 6.6.
We're just going to round it to 6.67. How's that? Times 10 to the 14th. All right, now, Caroline asked, what unit does frequency get? We flip back over here to frequency. Frequency has what unit? Frequency gets a hertz. Okay? Frequency gets a hertz.
this hurts.
I'm getting back there. So we're going to put hertz here, HZ. Now, for color, where do we find color at?
By looking at the chart.
By looking at the chart. Now, you can do it right here. There we changed it. Oops. Right here we changed it into meters.
No.
4.5 times 10 to the negative 7th meters. That's your wavelength. Okay? The chart's in wavelengths. So, if we cruise to where I have the chart. All right? This right here is in wavelengths. It's a number line. 4.0, 4.2, 4.9, 5.7, 5.9, 6.5, 7.0. You guys had 4.5, right? So where's 4.5 fall on this number line?
Blue.
Falls right there. So it's blue.
Yeah.
So the color would be blue. So those would be your 2 answers.
So we don't have to do any math to find blue.
No. Well, you already did the math. It's right there. Because you did the math with the chart.
C is color?
Huh?
What is
No,
C?
C is speed of light.
C is the speed of light. That was that 3.0 times 10 to the
Y
8th.
is wavelength.
Huh?
Y, the Y is wavelength.
Yeah, that's the upside down Y is called lambda, and that's wavelength. And that's V, that's frequency. That's new. Y'all got some studying to do.
Hey, question.
Oh, yeah, we really do.
Question.
Yeah.
Don't call it the lambda thing. That just sounds ridiculous.
Hint, hint, you have a quiz on this probably Thursday, and you need to learn the
So
names.
we got a test tomorrow, a test on Wednesday, and a quiz on Thursday.
Yes, genius. Did y'all hear what Anthony said? Say that again, Anthony.
We have a test tomorrow, test on Wednesday.
Do we have anything Friday?
Anything on Friday? It's possible.
You hate us.
I love y'all. Y'all are fabulous.
That's like
No, I'm meaner to them. All right. So, let's try another one. Y'all just heard there's a quiz on Thursday. It might be Friday. I might be nice since y'all have two guests around. I might be ready Friday.
Two tests, that's already.
Or you could be extremely lazy and we could just not.
Oh, yeah, that's fine.
Yeah, my brain is like really suffering right now. I'm on the verge of a C. So anyway.
Oh, well, I could just make it next quarter, you know, because Kareem's not gonna be here, Lewis is not gonna be here. I'm gonna have to do a makeup work, so we'll probably just put that quiz on the next quarter.
Oh, that'd be amazing.
I do warn you though, these quizzes usually. They just do. The test is usually really good. It's usually a really good test to start the quarter, but the quizzes are usually really bad.
That's 25%.
This is
25% of my credit's going.
This makes more sense than light can move a can.
It's not gonna move a can, it's gonna move an electron. Gonna move an electron, not a whole can. Alright, so what do we do first? And this is the question you gotta solve.
Right?
That weird.
We gotta do the weird chart. What weird chart?
The T.
Oh, the T chart, okay. I was gonna say, I wouldn't call that a weird chart at this point. We've been doing this a while, so this doesn't seem weird to me. So it goes on top, okay? What goes on the bottom? Nanometers. What goes on top? Alright, who's bigger, a meter or a nanometer? Good. How many nanometers are in a meter? 1 times 10 to the 9th. All right, you have to memorize the 1 times 10 to the 9th. No, it doesn't have a number or a name. It's just 1 times 10 to the 9th. It's just the nanometer number. Y'all stop calling it an avocado. Poor man. Okay. Now, this right here is lambda, and you use for color. Okay? Is everybody okay with that? Your wavelength, and you use it for color. Okay? That's your wavelength, and you use it for color.
So when we do the little conversion things, will it always be something times 10 to the 7?
Yes, because that's what's on your blue chart. So you're always changing it into that number that's on the blue chart, because that's your wavelength. Okay, so now we're going to do what? We could go ahead and find color now if you wanted, or we can go ahead and plug into C. All right, so C equals lambda. Nu is our formula. What's C? So what is it? Times 10 to the equals, lambda is 6.25 times 10 to the -7. And then V is what we want. So to solve, we do what? Yep.
Isn't that also blue? Which is yes.
Anybody already divided that?
Yeah.
What was it?
It was 4.8 times 10 to the 14.
Okay, so.
Okay.
You know you can.
Okay, I realized that.
All right, so we got 4.8 times 10 to the 14th hertz.
Yeah.
Okay, so to find the color,
It's orange.
I hear orange.
Orange.
All right, so 6.25, I agree. 6.25 falls there. Everybody okay with orange being there?
Yeah, sure. Can you come back to the?
I'm going back. I just want to make sure we're all okay because we were arguing a minute ago about orange.
They put it in the wrong place.
Oh, they used the wrong number?
Yeah.
Okay.
I used the wrong number.
What do you use, the frequency number?
It's not our
So
I'm
basically,
looking at the wrong
you just
number.
divide the speed of light by what
One
you
thing.
get from the chart and then.
Yeah.
Both.
So you're not using the answer.
So
We're not using frequency to get color because the frequency number is not on the chart. The chart is based on wavelengths. You see how it says wavelength here? Because that's wavelength, yeah, because wavelength. We can't use the frequency, and we calculated E, which is frequency. Okay? So we can't look up frequency, we have to look up wavelength. It's just a separate answer. So you're not going to necessarily put the two answers together. No, the number is not one. There's just two separate questions up there. So you want to give me the number and you want to give me the color. They don't have to be written side by side together. Okay? Who else has a question?
the color you always,
I think
the
it's
numbers that you get
like
from the chart is how you find the color.
The number you get from the T-chart is how you get the color, yes. Now, let me ask this. Do you have to do the T-chart to get the color?
No.
The answer is no. Okay, so let's say for a second that all I ask is color. You don't actually have to draw a T-chart. Suppose I tell you you have 550 nanometers,
You just look it up.
okay? All you have to do is change that to 5.50, and you've got what you need to find it on the chart. You don't actually have to draw the T-chart to get just the color, okay? So, yeah, you could do that. No, I just showed you the shortcut. Why would I take off for it? I'm showing you the shortcut for a reason. Okay? So you could just cruise over here and find 5.5, and 5.5 falls there, and you tell me the color's green. Now, would it work for being able to calculate? It wouldn't work for calculating because you need the exponent, but it would work for just telling me the color. Okay? Do you understand the difference? Whoops, wrong way. If all I do is want color, then you can shortcut it. And if you've got 600 nanometers and you want to know color, you can just say, oh, that's 6.0, and you can look up color. But if all you have is 6.0, can you plug it in the formula and get an answer? No, you need to do the work to get the exponent to be able to plug into the formula. But if all you want is a color, you can shortcut. Is everybody with me on that? Yes? Okay. Almaja's saying no. Why are you not with me, Almaja? Where have I lost you? If I give you some nanometers, like I say 425 nanometers, and all I say is what color of light is it? You can shortcut this and change it to 4.25 and just look up the color on, whoops, wrong way, here, and find 4.25 and go, okay, 4.25 is barely over the line and it's going to be a blue color. Okay, you can do that to find color, but you can't just, whoops, you can't take the 4.25 and plug it into the formula because you need the exponent that goes with it to be able to plug in. You can't do the shortcut to plug into the formula, but you can do it just to get the color of it.
So I have a question. Can you go back to the chart?
Yeah?
Okay, so that says what? 4.2?
Yeah.
Okay, so if
it fell on the line, I would. If it was multiple choice, I wouldn't give you both colors.
Oh, you recommend that.
Okay.
So how will we find it with the chart and not shortcut? The number to use for color play.
With the chart, it would be 4.25 times 10 to the negative 7. You would have had the whole number.
No, but like, how did you do that? Because I know we found out the chart.
I didn't even say that.
Is it, do you multiply it by the 1 times 10 to the 9? And use that number? The number we used, so we had the chart, we had animators on the top, animators on the bottom.
Yeah, we were using this.
Yeah, so that gave us the.
That gave us the color. We used that number, we looked it up on the chart.
So that could be used for light, the color of light and the equation?
Yeah,
But the other one can just be used.
just be used to read the chart, because you don't have the exponent on it. All you have is the number with the decimals. Yeah. Okay, now, I'm gonna give you something that's not due until Thursday. Okay? I just gotta find it. There it is. Alright? Not due till Thursday, and we're only doing 1 through 10. Okay, 1 through 10, and it's not due until Thursday. Because the rest of it we haven't learned how to do yet. It's all gonna be done Thursday.
Thursday.
Yeah,
Are you staying out tomorrow?
I'll be here always. I'll be here all week long.
Oh, I have so much to do. Don't talk. I didn't do anything.
1 through 10.
I have to finish everything before board series.
Huh?
Have your class.
1 through 10.
I have to write an introduction paragraph.